Okay, this is day 7 of the distance learning packet and the math section. All right, so our task today is on expressions and equations. So we have two different fruits, and we see a graph of their cost versus pounds. And just looking at the graph, since the line for the peaches is steeper, that would imply that they are more expensive, or the unit rate or cost per pound is higher. Okay, so part A, which fruit costs more per pound? So that's what we just talked about. There's no numbers, but we don't really need numbers. But let me see if I can illustrate. Let's just say let's just call this 1, okay? So just for illustration purposes, I'm going to draw a line, just a vertical line, so that we can see how those two lines affect the cost. So if I go up to the plums and then go over whatever this is, we don't have numbers again, but I don't know, let's call this 50 cents. Okay, and then we see that when we go up from the same line, from 1 pound, up to the line for peaches, and we go over to look at the cost, it's at least twice as much. And my line's not perfect, so let's just call it $1. So you can see that peaches cost more. So for part A, peaches cost more because I'm going to say the slope or unit rate, because if it's proportional, they both go through the origin, the slope and the unit rate are the same. And unit rate would be the price per pound. So I'll just say that price per pound. LB is pound. Price per pound is higher. Okay, peaches cost more because the slope or unit rate is higher or greater. Okay, B, bananas cost less per pound than peaches or plums. Draw a line alongside the other graphs that might represent the cost of buying bananas. So it is less than both of those. So if we want a line that represents bananas, and it's less than both. So again, it will start at the origin, so we just need to start there and draw a line. We don't know how much less, so is it just a little bit less than plums or a lot less, half of that? I don't know, let's just call that bananas. So anything lower than or a smaller slope than the one for plums. And that's it. It just says to draw that, and then we're done. All right, so next page, we have a rule 4. And this time we're given a table. And just like always, I will help you find the slope and y-intercept, and that will give us our equation. So if we have a table, we're just going to look at the rate of change. And so this says f of x, but remember that is just y. And our slope for a table is the change, the delta y, change in y, over change in x. So let's look at that. Okay, so from 4 to 1 is -3. Okay, from 1 to 0, that's -1. And then we're back at 1. So what's going on here? Is this a constant rate of change? On the x side, what's going on? We are adding 1, adding 1, adding 1. So that is constant on the x. But the change on the y side is changing. It's not constant. So it's first we're subtracting 3, then we're subtracting 1, then we're adding 1, then we're adding 3. So this is a non-linear function. And that means there's no slope. Could be a y-intercept, but there is no slope because it's not a straight line. So this is, I'm just going to call this, so this is not a straight line. Not a straight line. So it turns out this was put here on accident. It was the wrong table. This is actually for algebra. This is a parabola. It's a quadratic, so it's a curve. It's not a straight line. So we're not going to even worry about this. So let's move on. Okay. Here we have to determine if these are linear or nonlinear. So 8th grade, we only deal with linear. That's why we skipped this page, because this is nonlinear. We could still graph it. So if you want to just kind of prove to yourself what it looks like, let's just graph this. So 0, 0 is here. -1, -1, +1, -2, +4. Same on the other side. So you can see it kind of looks like a U. Okay, so this graph will be something like that. So this is called a parabola. You will learn this in Algebra 1. So it's nonlinear. So again, we don't have a slope. And the y-intercept, well, it's 0. It crosses at 0. We can write that. But the equation, you haven't learned it, so don't worry about it. Algebra, if you're an algebra student watching this, then you should be able to write an equation for this. All right, so anyway, the next one, we just have to determine if it's linear or nonlinear. So just like we did before, we're looking for constant rates of change. And if we get something different like this, it was -3, then -1, then +1, then +3. If it changes like that, then it's nonlinear. Okay, so let's take a look at number 1. So looking at the x values, they are increasing by 1 all the way. On the y value, we are increasing by 4, and then increasing by 4, and then increasing by 4. So this is linear. Okay, constant rate of change, linear. All right, number 2, x's are changing by 2, by 2, by 2, and then the y value is -2, -3, -4. So this is nonlinear. Okay, number 3, we are subtracting 2 on the x, subtracting 2 on the y, adding 4, and adding 4. So this one is linear. Number 4, let's see, 3 to 1, that's what? -2, 1 to 0, -1, and then -2. So that's already different. The y doesn't even change at all. Okay, so this is nonlinear. Okay, number 5. We have 3 to 0, which is -3, -3, -3. That looks good. On the y side, we have +5, +5, and also +5. So this is linear. Okay, these are functions. So that's another part, is function. So number 4, this would be, let's just see what it would look like. Because maybe it is linear, but it just looks weird. So let's see. 3, 7, 1, 7, 0, 7, -2, 7. So actually, it is a straight line. It's a horizontal line. So even though the rate of change looks weird, this one is linear. So it is linear. It's a horizontal line. Okay, number 6. +1, +1, +1. On the y side, +2, +2, +2. So this is linear. Number 7, x is adding 1, y, we're adding 2, adding 2, adding 2. This is linear. 8, adding 2 on the y, adding 1, and then adding 2, and then adding 6. So this is nonlinear. Okay, and what does it say in the box? Explain how you determine if the table represents a linear or nonlinear function. Okay, so we're just going to say if the rate of change or slope is constant, then it is linear. Okay, so let's go back to that weird one, because it didn't seem like it was constant. So let's just look at these 2 points and see what we get. So remember, change in y over change in x. That's what our slope is. So the change in y doesn't change, so that would be 0 over negative 2. What's 0 divided by any number? 0, right? So let's take a look at, well, let's just look at the next point. So we have, again, 0 over negative 1, which is still 0. So it is constant. It's 0. The slope is 0, which we saw that in our graph. A horizontal line has a slope of 0. All right, let's move on. Okay, we have a description. It looks like it is a description of an equation. So let's see if we can write this out as an equation. So it says 6 less than 7 times a number is equal to negative 20. Well, the first part is equal to negative 20. Okay, got that. Equal to negative 20. Okay, so this first part, let's read it again. 6 less than 7. So you have to be careful. If you stop there, 6 less than 7, that's just 7 minus 6. But this other piece is very important. Times a number. So we have to group this, so kind of like order of operations. So 7 times a number, so this would be a number, just x, right? So 7x, and then 6 less than that. So how can we write that? 7x minus 6. So 6 less than 7 times a number is equal to negative 20. Okay, so that looks good. All right, so here's an equation. We're just going to solve it. The x is already by itself, or it's already on one side of the equation, so we're going to eliminate those other numbers. Okay, so that makes it 0. So we have 7x equals negative 14. Okay, and then we divide both sides by 7. Okay, that's a 1. So 1x on the left, or just x equals, and then negative 14 divided by 7 is negative 2. Okay, and then graph the solution. They already give you, it's just a number line, so it's just a single value, x. So you can, draw your number line however you want. Put a 0 in the middle, negative 1, negative 2, and then we're just going to put a point on negative 2 right there, and that's x. X equals negative 2. And that's all for day 7.